sites, investigative technical sites, with CHOP, the Children's Hospital of Philadelphia, as the lead institute. The overall PI is Adam Resnick, and he and his team were funded just a little over a year ago, as of last July. The work of constructing this data resource center was divided into 3 cores: a data coordination center, administrative and outreach center, and a data research team working on a data research portal. Their stated goals are in this slide, but I'm just going to touch on some of the accomplishments that they've done in this brief last year. Okay, the data coordinating center is charged with taking in the genomic, phenotypic, and clinical data, and that's surprisingly difficult. These are huge data sets, as you probably know, and so just piping over data to a cloud resource and having control over it is actually quite a challenge to arrange. They are also charged with constructing a CITD controlled ontologies, and this is a source of continued improvement and a lot of interest and hopefully powerful tools for analysis. The genomic data coming into the Kids First data resource is being harmonized against the latest reference build of the human genome, and they're using an optimized and scalable pipeline. So all the data sets are harmonized the same way, and that makes it easier to bioanalytically compare and search data sets. Again, that's actually a pretty huge project. Well, the Data Resource Center as a whole recognized that the patient and clinical communities can and should be able to access and contribute to the research. So they recognize that we have partners, not only the researchers, but also healthcare professionals, the patients, family members, and the interested community. So they've done outreach both to help design the data portal and the website. They went through a process of having community meetings, at least 3, with the interested community, getting feedback on what features were desired. One of those features of the Data Resource Center was a call for more outreach. Especially the artists and community, they wanted to know about the researchers, they wanted to know about the projects, they wanted to know about the Data Resource Center itself, and they wanted to know about scientific progress. So the Administration Outreach Corps has developed flyers and keynotes and posters for social media with investigator spotlights and spotlights for the community interested efforts of community groups, so that some developments can be better coordinated. Okay, finally, again, the group to assemble and index and put together frameworks, but it's not very useful if you can't access it, and it's not easily accessible. So an important part is the data resource portal. The PI of this part is Vincent Karate, and they're charged with, and I believe have been successful in a very short time, in developing a compelling user interface that will let users of all skill levels browse, visualize, and perform in-place analytics across the Kids First and related data sets. Of course, these are controlled access data sets, so it was necessary to integrate into this a framework from the Gen 3 platform that allows controlled access of the data sets. And they also integrated in Kavatica, which is sort of I'm not a bioinformatics person, but I sort of view this as a Santa's workshop, where you can import power tools, as it were, into the workshop and set the L's on working on your data sets. It really looks intriguing to me, and you'll see a little bit of glance of it in a minute. I can't really convey how this data portal looks and feels and how useful it might be. So what we're going to try to do is show a quick demonstration of the portal. You can do this yourself. Go to the kidsfirstrc.org website, click on support, and get started. Come on. Scroll. Oh yeah. Forgot about that. Scroll down, and down here is a quick demo of this first. Now they only have a year to work on this, so this is the first iteration, and it will certainly be interactive on. But it's pretty impressive, and it's supposed to work.
gathering information about themselves and interests. In this major setting, this is part of the integration area. Right now there's two integrations. In the University of Chicago, the Gen 3 Data Commons, which allows people to gain access to data through the NIH JET program. And then the second program, Seven Bridges, Kavatica Workflow Platform, which will allow you to quickly analyze data from kids first Firefox in an online cloud environment. So that's page that users can interact with the file repository. You can see on the left data features highlighted in the browser, as well as the table of files with some staff and actions that you can take on those, including downloading a manifest or a report. If you like the file that you interest, you can download that information. Another thing that you can do is identify multiple sets of information and then push those files onto the Kavatica platform to analyze data in the cloud. Before we do that, we want to make sure that users have permission to access the files. Maybe I don't have access to one set of files, even copy code, but I do have access to several different files. If something allows the process, we copy the files right over. Once I'm in Kavatica, I can check and see that all of the files are listed in order, that I can copy over, in addition to any other files that I have for workflow usage, like reference genome, input data sets that workflow supplement them. In Kavatica app area, I can add apps to my workflow area. I can set to public apps, add them to my project, or I can create my own app. So for kids first, a custom Just Genome Technique workflow app has been created. I've already set up a demo task that shows what this would look like, so from the task tab in Kavatica, we can see the Kids First Joint Genome Technique workflow that starts with going into that workflow, you can see all of the steps on the prior to test, and then select the address that you chose from the portal. So I'm going to be looking for GBPF files that are organized. Once I found the correct file, I can select them and save them to the workflow, which you can now see about to evolve. And then I need to use output. And I can click off the workflow, which is first data. You can see that it has queued up. In my task tab, I can see a list of all the tasks. In my collaborative environment, I can see there are other tasks that are running as well, and even one that has failed that I might need to go in and fix something about one of the assets or the file library.
I'm supposed to stop that. Okay. If I can get back to my... I don't know that I can. On the bottom? Yeah. Right. Okay. Okay, so I don't know about you, but I'm pretty impressed in what they built in 1 year's time and looking forward to the future. This is a very dedicated team, and I think they're doing fantastic work. Okay, back. This is a timeline, sort of overview of the Kids First program. In the first couple of years, we only did sequencing, and then we've continued that and expect to continue it through fiscal year 2012, building the data sets, the data resource. We funded a data resource center, and that funding will at least continue through 2012. We've issued RO3s for data analysis, and we'll continue to do that at least through 2012. 2021, sorry, dyslexia down here. The last 3 years of the program, however, are sort of terra incognita. We have no idea what we're going to do. That's not true. We know a lot of possibilities that we could do, but we're just now embarking on planning for that, for those years. One of the important to get the data resource we built, and some possible projects to consider are justice work, strategic curation, funds to recruit, and where we consider cohorts of affected children, training and demonstration projects, and of course developing animal models will be important, or it's likely to be important, and your suggestions are something that we very much wanted. Finally, since this is a collaboration day, I want to talk about a very recent collaboration. I think we found out about this less than 3 weeks ago, so it's pretty fresh. We're trying to move it yet for NIH standards, the speed of light here, to get this up and running. The collaboration has developed mouse strains to study phenotype and validate coding and non-coding genetic variants identified from Kids First whole genome data sets. We want the community to invite and to nominate variants identified through analysis of Kids First data sets for mouse model production and phenotyping to take advantage of the powerful production pipelines and phenotyping pipelines that COPS developed. We've put together a team of NIH program officers to evaluate these. We call that an administrative review, to evaluate the nominations. If you have a variant to nominate, I'm giving you the information on this slide. If you have a series of variants to nominate, you don't need to fill out 3 pages for each variant. What we'd like is what we came up with during scrubbing is this set of information. It's likely to evolve as we see what comes in, and if we need more information, we'll come back to additional questions. As I said, in order to get this moving, the nominations are already being reviewed by a subcommittee of NIH staff from the Kids First Working Group. The variants will be prioritized basically based on the strength of all the supporting evidence. In other words, whatever you tell us is important. Maybe that's the case. And decisions will be finalized in consultation with the COP2 staff. So again, we're moving very pretty rapidly. Our first deadline will be October 26th, and if we need more information, it will be requested after our preliminary review. If you have technical questions about the variant production, you can go to this email and talk to them and answer those questions. And KidsFirst want to use this as a pilot for how to evaluate nominations and pilot a process here for feedback to see how it's within the laws and how to go about vesting accumulated nominations with the idea of having support for violent increasing nominations using KidsFirst programs outside the picture community, but certainly in the mix already as well. So finally, I want to encourage you. What we have is so that we cite the human genetics information in a healthy, professional, and social, as it were, so that you can meet KidsFirst cohort PIs. We can talk about collaborations. We can get your feedback on what you should be doing in the program. And Data Resource Center staff will be there, as well as people from the KidsFirst program. And we're hoping that this will be a truly interactive meeting. And again, we're hoping to have meeting structures that are maximally productive. I have to say, I haven't encountered an NIH group that is as motivating as this group, and we're constantly trying to innovate and tailor our program to use the money Congress has given us to the best effect, and we'd love your feedback. So you can catch me here, or you can contact me. You can find out more about the program on the Common Fund website for KidsFirst, and I guess we're not going to take questions, but we can get your break now.
Hi, everybody. So my name is Kate Rowan, and I'm the Chief of Genomic Medicine at UC Davis, and I've been tasked with the opportunity to talk to you a little bit about what in the world is clinical geneticists, who are we, what do we do, what is medical genetics or genomic medicine, and really what is it like day-to-day, boots on the ground, of meeting patients, talking to patients, and trying to make a diagnosis. And in the next few minutes, just marking my time here, in the next 20 minutes, we're going to talk about a little bit about a grassroots relationship that grew with Kent Lloyd and his group at the Mouse Biology program at UC Davis, and how we're moving forward with what is truly a really great collaboration. So I really want to thank the organizers for this opportunity to speak to you today. So I'm going to give you the punchline right now. You don't even have to wait. So the work that you guys are doing right now, creating these mouse models and phenotyping them, is critically important to the work we as clinical geneticists do on a day-to-day basis. So I heard the conversation yesterday about getting your papers published. Get your papers published, because we look at those every single day. We are searching and looking on PubMed for genes and variants and stuff like that that we need to learn more about, and how it relates and how it could relate to the human condition. So get your papers published. They really do matter. So genomic medicine, I just want to talk a little bit about genomic medicine at UC Davis. And the NHGRI defines genomic medicine, and here I quote, "It's an emerging medical discipline that involves using genomic information about an individual as part of their clinical care, for example, for diagnostic or therapeutic decision-making, for the health outcomes and policy implications of that clinical use." So it's great to see that genomic medicine is being defined, but I can tell you, we have been doing this for a very long time. And the fact that you may not know what a clinical geneticist does or what medical genetics is and how it relates to the medical community, that's okay, because physicians at our own institution don't even know what clinical geneticists do, and some of them don't even know that we exist. And so having the NHGRI make a public statement about what we do and who we are is really great, and it's a great first step. So our mission of genomic medicine at UC Davis is to help improve the quality of life for individuals, both children and adults. We see the entire lifespan. Genomic medicine is not just a pediatric subspecialty. We're our own residency program, and so a resident can come through after medical school and actually board in clinical genetics. So we see both children and adults, and family members of individuals with genetic disorders through excellent clinical care, through research and scholarly activity, and education. We do a lot of education. So again, what in the world is a clinical geneticist? Very basic, but a lot of physicians don't even know, as I mentioned before, that we exist. So clinical geneticists are specialized physicians who diagnose and treat patients with inherited or otherwise genetically influenced health issues. So what's a genetically influenced? Like fetal alcohol syndrome, right? In utero exposures. They organize screenings for inborn errors. They prescribe therapies. They interact with genetic counselors. Well, what's a genetic counselor? Genetic counselors are professionals who have specialized education in genetics and counseling to provide personalized help to patients that they may need to help them make decisions about their genetic and genomic health. Genetic counseling is a super, super hot career right now, and the fact is genetic counselors are being scooped up by industry, and it's really hard for academic centers to hire genetic counselors because we have a much lower pay scale. So this is a typical, I'm going to describe for you a very typical genomic medicine or medical genetics unit. We are housed within a clinical department, and it's typically pediatrics. I transferred to UC Davis from UCSF almost 5 years ago, and when I transferred to UC Davis, my job literally was to rip down the division and rebuild it, and that's what I did. And so the people that I'm going to describe for you are typical geneticists are new hires that I've hired. So I am a physician scientist, and the thing is, genomic medicine is such a broad field right now. You saw the talk this morning. We have 20,000 genes in our genome. There are about 6,000 million disorders described. And so how do you wrap your head about trying to find out from a phenotype what that genetic lesion is? So I'm a physician scientist. I see patients. I run a lab. I do mouse models, but I don't do knockouts. I actually have my mouse models are activating mutations. So HRAS, and BRAF. Maddie Martin is a biochemical geneticist, and actually she sees patients that have very specialized disorders and biochemical derangements. She's also a clinical geneticist. So again, medical geneticists actually specialize because it's such a broad field. Wendy Martin, she's a clinical geneticist. She's also biochemical. Her field of expertise is genetic genomics. Chris Herman, also a clinical geneticist. She actually specializes in connective tissue disorders, skeletal dysplasias, and prenatal genetics. And Suma Shankar, that you'll hear from later today on the panel, she's also a clinical geneticist. She specializes in ocular genomics and precision genomics, which I'm going to talk more to you about. And then Eva Liu is a genetic counselor. And so we have 4 fantastic genetic counselors. And again, the field is so broad that even now genetic counselors are specializing in areas. We have Viv, who specializes in neurodevelopmental disorders, autism genomics, precision genomics. Becky specializes in lysosomal storage diseases, and she also sees general genetics patients. Colette specializes in cardiogenomics, and she also is my coordinator for the vast pathway clinic that I have. And then Agata is biochemical genetics and newborn screening. So again, specialized care. In our genomic medicine division, we have lots of different clinics. General genetics clinic, biochemical genetics clinic. I do the NF-RAS pathway clinic, connective tissue disorders, cardiovascular, lysosomal storage, telegenomics. So Davis is a really big leader in telemedicine. Autism genomics, precision genomics clinic, and ocular genomics clinic. Lots of different clinics. Again, at the University of California, ours is a very typical genomic medicine division. And so if you were to go to UC San Diego, or UCLA, or UCSF, again, very similar to what we do at UC Davis. Inpatient, we see about 300 cases a year. Outpatient, and these are underestimating, outpatient we see about 1,000 cases a year. And again, all ages. So when I transferred to UC Davis from UC San Francisco, the one thing that I knew we needed to do was we needed to build precision genomics. Because I honestly, in my lifetime as a clinical geneticist, I never thought we were going to be sequencing the genome. And it happened all of a sudden, and I'm so thrilled because it makes our day-to-day amazing to be able to sequence the human genome and try to figure out what in the world is going, how can I apply it to the patient, and then most of all, how can I help the patient with their health issues. So when I got to UC Davis, my very first recruit was trying to get Suma Shankar from Emory to come join me at UC Davis and to really run a precision genomics program there and set up a clinic. And so the goal of the precision genomics clinic, successful thank goodness, as she set it up, was to provide answers to families and individuals with suspected genetic conditions that are going through the diagnostic odyssey. And you heard about the diagnostic odyssey already this morning. Genetic medicine is one of those fields of medicine that we are typically the last resort. The patient has gone to cardiology. The patient has gone to immunology. The patient has gone to pulmonary. The patient has seen every medical specialist and has done every single test, and they still don't know what's going on. And so what happens is, well, we don't know what this is. Let's just send them to genetics. So we typically are the last one to see the family or see the patient. And so our goal is to try to end that diagnostic odyssey and to try to figure out what's going on. And so patients that, again, have a wide range of medical issues throughout their lifespan, this is the patient that comes to see us. With the goal of benefiting the patient and the family, we're trying to drive personalized treatment options. We're trying to drive discovery and collaborations and advanced medicine. So when Suma came, what she did was she took a very systematic approach as to what was going on at UC Davis. Again, pretty typical for a University of California division of medical genetics or genomic medicine. So we see about 1,300 patients per year, as I said, and let's just round it off to 1,000 outpatients. So what Suma did over a year's time is she retrospectively went back. We're housed at the Mind Institute at UC Davis, which stands for the Medical Investigation of Neurodevelopmental Disorders. And so a lot of what we see and a lot of our referrals are developmental delay or autism spectrum disorder. And so about a third of those 1,000 patients that come to see us on an outpatient basis are developmental delay and autism spectrum, query diagnosis or genomic diagnosis. And so what Suma did was she evaluated the genetic testing approach that we were using, and she wanted to look at the yield for autism spectrum and developmental delay in our division. And so a typical appointment is we gather clinical information. We try to get as much information as we can because that's part of the phenotyping. So again, what we do is very similar to what you do. We just do it in a reverse order. We phenotype and try to find out what's going on in the genome. You guys create a mouse model, you alter the genome, and then you phenotype. So we gather as much information as we can. We do a very thorough medical physical examination, and we try to phenotype as much as we can. If we can, and if insurance allows, we'll try to get an echocardiogram. We'll get an abdominal ultrasound to look at the liver, the kidneys, and the abdomen, and anything else we can get our hands on. We'll try to get an eye exam, a hearing evaluation. Again, really phenotype that patient in a systematic way. And then based on the phenotype, we want to target the type of testing that we do. We don't just send whole genome on everybody.